Hello, everyone. This session is recorded because some of you still haven't done this exercise yet. This was given to you on Wednesday this week. Now, if you haven't finished, please go to finish and then hand it to me. And then after I give it back, you can watch this video. Question 1. Find the derivative at x equal 1 from the first principle. So I'm going to use the first principle based on 1. F prime 1 is equal to e to the power 1 plus delta x minus e to the power 1 negative 1. Yes, negative 1 plus delta x e to the power negative 1. In the next step, I will take out e to the power negative 1. Now, when I take it out, this one has e to the power negative delta x left, and this term has negative 1 left. Now, some students are confused by this negative sign, but if you observe carefully, you can see that another negative sign here is added. So these two can cancel each other out. So you don't really have to consider the negative sign in your factorization step. So when you factorize, you just take out e to the power negative 1. Okay? I think 90% student made a mistake here. They didn't see there are two negative signs in this step. And then I can take out the constant, negative e to the power negative 1, leaving me e to the power negative delta x minus 1 divided by negative delta x. And this is a special limit. And the 1 mark is given if you know the special limit. And the answer is negative 1 over e. Question 2. Find the derivative of this implicit function. So the first step, ddx on both sides, ddx on both sides. And then this is the function y, so I will do dy dx, ddy dx, negative y negative 2, and dy dx. This again is ddy and then dy dx, cosine 2y times 2. And then you just simplify. This is 2y squared cosine 2y minus 1. Okay, and the answer is there, the first derivative. For the second derivative, I will do ddx on both sides again. On the left, you have the second derivative. On the right-hand side, it's ddx, a function of y. I change it to ddx, ddy, dy dx. Okay, so here I'm doing ddy immediately. Now, some students find filling in blanks is much harder. This is because you don't know what method I'm going to use. Now here, because I choose to use the chain rule first, so this is my step, I will only do ddy in this part, and then I will multiply dy dx just once. And some of you are not, this may not be your first choice, and you may do something else, and then eventually you get the same answer, but because you're using a different method, so you find filling in the blanks so difficult. But my suggestion is you try figuring out what I want you to do. So this one is 2y. You see, I don't multiply y prime anymore. I just do 2y because I'm doing dy only. So this is 2y times low minus d low. You see, d low is a huge piece. D low times high. This is high. This is high. y squared is high, and d low is a huge piece, this part. So d low is 4y times cosine 2y plus 2y squared times negative sine 2y times 2. And then, of course, minus 1 becomes 0 after the differentiation. And then divided by the low square. So d high low minus d low high divided by low square. Multiply dy dx. You see, I multiply just once at the end. Now with the simplification, I will just take out a few things. For example, I'll take out y, leaving me 2y squared cosine 2y minus 1 minus y, right? And then bracket 4y cosine 2y minus 4y squared. I hope I'm not wrong. 4y squared sine 2y. Okay. And in my next step, I take out even more things. I take out 2 again. So I have 2y squared cosine 2y minus 1. And for this one, I take out 2. I will have minus 2y squared cosine 2y and plus take out 2. So 2y cubed sine 2y. And then you can have the answer. You see? Now I get 2y squared from here. 2y and y squared. So 2y cubed. And then everything is factorized. Let me say it again. In this part, in this step, if you didn't choose to do d dy times dy dx, the steps are completely different. Next one. Differentiate on both sides. d dxx, d dx 3y, take out 3. And then d dx log y, that's 1 over y, dy dx. So you will have 3 plus 1 over y times dy dx equal 1. And then you have the answer. Question 2. The ddx on both sides, left is 1, right hand side is change it to dy dx. So cosine y, and then this one is e to the power 2y times 2. So this one is cosine y plus 2e to y times dy dx. So dy dx is found. For the second derivative on both sides, d dx, and then you see again, immediately I change it to dy dx. If you didn't do that, it's not impossible. It just means you don't know what the rest of the question is doing. So try to understand the step. So I change it. This whole thing is a function of y, so I can change it just once. Let's change it to dy times dy dx, and then I can focus on this part of differentiation. Okay, so change it to dy dx, and then you need to differentiate this fraction. I know that your first reaction towards a fraction is to, let's apply the quotient rule. And that's very natural and very normal, and it's not wrong. It's not wrong. If I leave to you a blank piece, and then you just differentiate yourself, and then you probably get correct. But here, some of you are confused because there is a negative sign in front, and they don't know why there is a negative sign there. The reason there is a negative sign in front is because I want you to differentiate this part without the quotient rule, without. And you may say, how can I do that? This is a fraction. It is a fraction, okay? It is a fraction, but it's also a composite function because I can see this as u to the power -1 and u equal cosine y plus 2e to y. If you see it this way, and then this is not a quotient anymore, it's a composite function. And that's precisely why there is a negative, this differentiation has -1 over u squared. So you can see it's -1 over u squared here, and you only have to multiply u prime. Okay, so what you do here is to write in the derivative of the u, which is cosine y plus 2e to y, leaving you negative sine y plus 2 times e to the power 2y times 2. That's why there is a negative sign in front. Now, when I create this file, I say, oh, please must understand the step. Eventually, this is how you understand it. If you use the quotient rule, then you cannot understand the step. Now, we have a very similar procedure in the next question. Question 3. ddx on both sides, and then the left hand side is 1. Right hand side, again, I change it to dy and then dy dx. You see? Again, there's a negative sign in front. It's a similar procedure. I'm just doing -1 over u squared times du dy. That's why there's a negative sign. Okay. And then the first derivative is found, and the second derivative. You see, ddx on this side, change it to dy and dy dx, and then this one I have to use the quotient rule. This one, quotient rule. The negative sign here is from this negative sign. So when I differentiate, I do not consider the negative sign anymore. It's already put in front. I have d high low, this is low, minus d low high divided by low square, you see? D high low minus d low high. D high low minus d low high. And then I simplify. Now when I simplify, I will just take out something I do not expand. Now you may see, oh, why is the negative sign gone? Because the negative sign is cancelled by this negative sign at the end, so you don't have a negative sign. So I only take out e to the power y plus 1 and e to the power y. So what's left? E to the power y plus 1, e to the power y. I have 2ey left. This one, e to the power y, e to the power y plus 1. I have e to the power y plus 1 and then minus 1. I change it to minus 1. And then in the end, I have e to the power y minus 1. So this is the end. In the textbook, the answer is given by e to the power 2y minus 1 times e to the power y plus 1 squared and e to the power 2y. These two are equivalent. Because I think this standard answer is just, they put these two together. And then you get this. But if I keep them factorized, I'll get this answer. Next one, question 4. Binomial expansion 1331. It's not a code. I'm just giving you the binomial coefficients. So this is 1 minus 1 minus 3h minus 3h squared minus h cubed. And then you put in. This is first principle used on 1. So 1 plus h, f of 1. And this one is 1 minus 1 cubed. Just 0, basically. And then in this step, you must simplify. By simplify, I mean the denominator must be gone. So you're left with 3 plus 3h plus h squared. One of them is deleted. One of the h is deleted. Question 5. This is the first derivative to use the first derivative to find the log function, the derivative of the log function. So I believe it's x plus delta x. And then it's x plus delta x divided by x. I believe it's 1 plus delta x divided by x. And I believe this is 1 over x in order to balance. And then I will change it, this one, to 1 plus 1 over n. This is x divided by delta x to the power n. Now this part and this part must be identical, and both tends to infinity. Okay, and then you can see I secretly changed the position of the limits. It's function of the log equal to the log of the function. And then I have e to the power 1 over x. The whole thing here is e. This part is e. And then it's 1 over x log e. The final answer is 1 over x. That's it. I think if you're interested in the marking, 1 mark for the definition of first principles, another mark for definition on E, 1 mark for the log property. I guess you used log property somewhere here as well. Maybe that mark can be awarded to you if you've done something there. And then the final answer. Next one. Trigonometric function. First derivative. Not first derivative. First principle to find the derivative. X plus delta x. Sum to product. 3x plus 3 delta x plus 3x divided by 2. 3x plus delta 3 delta x minus 3x divided by 2. And then I will have 3x plus 3 over 2 delta x. And this one will go here. That's 3 delta x divided by 2. Now in your version, I'm left out the coefficient 2, but I already made it up. I made it up. So there is a coefficient 2 there. And then I separate this part and this part because I know one is a continuous function at 0. One is a special limit. Special limit. So this one, you just copy. This one, I will just try to compensate here. Here I divide 3, I multiply 3, I divide 2, I multiply 2. Now it's not like, oh, I have to write delta x. Some students wrote their delta x here. You don't have to, because I'm just making changes to the coefficients. You see, let me say it again. Here I divide 2, I divide 3, I multiply 3. Here I divide 2, I multiply 2. that's how you make it. That's how you compensate the coefficient. And then the final answer. Next question. First derivative on the polynomial. X plus delta x. Binomial expansion 1, 4, 6, 4, 1. So 1, 4, 6. 4. One. Now some students wants to put a bracket here. Now I don't know. But for me, delta x can never be separated. So I don't put a bracket. But in the answer, I put a bracket for you. So you understand, oh, this is delta x, not delta times x. It's one thing. And then you put them together. Some of the terms are deleted. And you're left with this divided by delta x. You're left with 8x cubed plus 12x squared delta x plus 8x delta x squared plus 2 delta x cubed. And then in the end, delta x is 0 here in the end. So that is the derivative of this polynomial. Next. Radical sign. Now here you need to multiply the conjugate. Usually we do that to rationalize the denominator, but here we use to rationalize the numerator. And then you can see how it's simplified. And that, and that, and that. Now, one thing that I don't do is that in my in the lessons that we had, I never expand. Now I will keep the denominator this way, but in this question, it's already the denominator is expanded. It's not wrong. It's just not recommended. You see, it's expanded, and then you have two terms, but that's okay. That's okay. In order to prove it, I guess you have to expand. Anyway, that's the first question. The second question, the derivative. Derivative is x plus h and minus f of x. And then it's miraculously changed to x plus 2 plus h minus 1 over x plus 2. And here I put a question, why is x plus 2 put in a bracket? Now, if you see the purpose of this, then you don't have to do the expansion all over again, because you're going to use the result of the first identity you just proven. If you substitute x plus 2 into this identity, I mean to replace x with x plus 2, then you can get the answer immediately. So here I have x, I'll put x plus 2, x plus 2. X plus 2, x plus 2. In place of x, 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 I put x plus 2, x plus 2, x plus 2, x plus 2. Okay. That's how you use the identity. You just prove it. I know you can do it maybe without the identity. Maybe you can do the rationalization again. But that will make the first part of the question meaningless. Like, why do we prove that, right? And then you simplify. You see, after that, the h is gone. Sorry. H is gone here. This h and this h, they delete themselves. And then you are done with a good function, what I call a good function. A good function's limits can be found just by substitution. Question 9. Cosine for pi plus h minus 4 pi. Now this is first principle used on pi. Okay. Now during the lesson, I always say when you have this, you have to use the product to sum to product. But in this question, it shows to you that that's not the only solution. Other identities can also be used. Now cosine 4 pi is equal to 1. That's how you get -1. Okay. And then this identity is used. You can see it's co A plus B. It's co A, co B minus sine A, sine B. It's compound angle formula, not the sum to product formula. Anyway, it's useful. As cosine 4 pi equal 1 and sine 4 pi equals 0, I will have cosine 4 pi minus 1 divided by h. And then I'll use the double angle formula. I use the correct double angle formula, 1 minus 2 sine 2h squared. The correct one. And then I'll get this, right? On the next page, because here I multiply 2, so that means I divided 2, so I need to multiply 2. So here, a lot of you didn't get it. The coefficient becomes -4. The final answer is still 0, but still, the coefficient is -4 now, because you see a slight change. You should realize that as well, because you're trying to use the special limit. Anyway, next question. Question 10. F prime. F prime. I don't remember the question, but I think f of x is given to you as x squared e to the power 3x, I think. So it's 2x and then e to the power 3x times 3, and then that's 3x squared plus 2x. The answer is given this way. Now you can see that x is not taken out. It's not fully factorized. This answer is seen as the most simplified answer is because I separated the exponential function and the polynomial function, and that's it. I just need to separate them. If you want to take out x, I think it's fine, but it's not good for your next step. In your next step, you will differentiate 3 to the power 3x, and then you will have 6x plus 2. You see, it's easier this way. It's 9x squared plus 6x plus 6x plus 2. Now, I think if you take out x and then your next step, the second derivative, it's harder, because you have to consider a product. I don't want a product in my differentiation. I want it expanded for my differentiation. So that is the best way to go. Part B. Part B. Now, if you read the question, you understand, oh, the final answer is the final question, oh, find the value of x to solve the equation. So this, you must understand this is not an ODE. An ODE is a differential equation in which you should find the function, not find x. Because in the end, you will find x, so it's not the differential function. Differential equation, not a differential equation. You put the result inside and then you factorize. You take out and you have 9x squared plus 12x plus 2 minus 15x squared minus 10x plus 2x squared, right? And then you will have -4x squared and then plus 2x plus 2 equals 0. And then it's an equation. You will find e to the power 3x equals 0, but rejected because it can never be 0. Some of you don't realize, but e to the power anything cannot be cannot be 0 ever. And the other part, negative 4x squared plus 2x plus 2, and then you will have two answers. One is 1, the other one is negative 1/2. Okay. I guess. Next one, 11. This is just normal differentiation. It's not implicit or anything. So d high, low minus d low, high, and you take out. And then the final answer, negative sign, is put in front. The second derivative, the negative sign is put in front. So again, d high, low minus d low, high. And then you take out e to the power 2x. That's cosine x minus 2 sine x minus 2 sine x minus 4 cosine x. And then you have the answer. The final answer, you don't have a negative sign because the negative sign is gone basically. Part B. Part B, again, you see this, it's an equation, but it looks like an equation. It looks like one, but it's not one. Let's first simplify and then you try to understand. Now you put the second derivative and the first derivative inside, you have this, and then all of them have the same denominator, so it's fine. You would just put them together by 3 cosine x plus 4 sine x minus 4 sine x minus 8 cosine x plus k cosine x. Okay, and then it's deleted this way. This one is k minus 5. You get this equation. Now in this equation, you must understand I'm not looking for x. In the previous equation, you can see that in the end I will find x. In this equation, I don't find x. I don't say, oh, k minus 5 equals 0 or cosine equals 0. Because the question says this is an equation for all. Implied, this is not an equation, this is identity. So in an identity, if anything equals to 0 forever, for any value of x, that means the coefficient is equal to 0. That's why we have k equal 5. Please. I think it's very confusing as to exactly what it is when you see something is given to you. Like in this part and then in the previous question, you can see that they look exactly the same, but the question is different. One is an equation, the other one is identity. Now in the textbook, we also have examples when you have to prove an equation, and that equation is an ODE. So try to educate yourself, if not now, but later on when you revise. When you're doing other exercise, you must remind yourself what you're doing, what you are dealing with. I think it's more important than solving it. This is equation, this is ODE, this is identity. Then you have completely another direction. Okay, last question. Now this one is the logarithmic differentiation, because after log, it's easier to differentiate. That's why we use it. So log w equal this, and then simplify. And then to differentiate is easier, although it's implicit now. So 1 over w dw dx. That's the only implicit part. On the right-hand side, it's still explicit. Still a function of x, so ddx still works. So ddx 2, 1 over 2, 1 over 2, and then you have the answer. Part B, again, it's a function between w and y. I use the logarithmic differentiation, unless you want to use the other method, but this one works. This one works. So after log, you have 1 over w. That is ddw on both sides, and then ddw on the right-hand side is dy dw. And then you find dy dw. Now, how about dy dx? The dy dx equal to dy dw times dw dx. That's just a chain rule. You can use it on anything. You can use it on anything. So this is always correct. And then you put in 1 over w log 3. And then w is cancelled. This is the answer. That's all, I guess. That's all for this recording.